everyone. For today's lesson, we are going to learn how to graph quadratic equations or quadratic functions in intercept form. For this lesson, you will need the following items. First, of course, you'll need something to write with. A pencil or a pen is perfectly acceptable. You'll need a graphing calculator or the capability of being able to follow along with the graphing calculator, and like a highlighter or some other color to go along with our axis of symmetry, as well as the analysis that we will have with a couple of our story problems. So once you have gathered these materials, go ahead and get started with this lesson. Otherwise, you might need to pause the video to make sure that you have these supplies. All right, here we go. Today's lesson, our learning objectives is for you to be able to say, I can graph a quadratic function that is written in intercept form using the x-intercepts and the vertex. I can write a quadratic function in intercept form given a table of values. So this table of values is going to be very similar to the other table of values that we have worked with, where we are going to be analyzing the second differences again. So here is the graph of intercept form of y is equal to a times x minus p times x minus q. So what you will see here is a graph of a parabola in which this parabola is not the parent function. It is instead a parabola that has two x-intercepts that are visible. We will still have a vertex, and we will still have, even though it's not written here, a dashed line of symmetry. All right, here we go. The graph, the x-intercepts, the vertex, one other point, and its reflection point is what's going to be the expectations. The one other point is just a recommendation. It's not something you absolutely have to do along with its reflection point. It's just something I'm going to put out there as something that you could do in the event that your graph doesn't work. So I'm just going to put that aside. Don't worry about it if it doesn't make sense. So instead, we're just going to focus on graphing the x-intercepts, the vertex. Those are your 3 points that you are going to need. You'll need one other point in the event that there's only one x-intercept. But in general, intercept form has x-intercepts that are located at p, 0 and q, 0. They are inside of parentheses, so they are opposite of what you see. So these are parentheses, or the opposite of what you see. So if you have an x plus p, you'll have a negative p0 in your x-intercepts. And these 2 points are always going to be the first 2 points that you're going to plot. The x-coordinate of your vertex. So if you think about it, a parabola is symmetrical. And so if these are your x-intercepts, what they have in common is the y value. Their x values will be different. And so to figure out where their x values are, they are going to be equidistant away from our line of symmetry or our axis of symmetry. And remember that our axis of symmetry comes from the x part of our vertex. So because it is the halfway between the x-intercepts, you can find it by using x is equal to p plus q divided by 2. The y-coordinate of the vertex is found by substituting x equals p plus q divided by 2, which is the x-coordinate, into the equation. So your vertex is going to be p plus q divided by 2, comma, some y value. You'll substitute this number into your equation and then solve for y. Now, this OPT is what this statement is all about, and I'm just going to say that this is optional. And this is especially helpful in the event that you only have one x-intercept instead of two. So if you were to let x equal a different value and substitute this number into the equation, this is called the one other point. Which is labeled OPT, so there might be some assignments where they will ask you for the OPT. I'm just putting that out there. If you don't see it, don't worry about it. And you will plot this point, and then this is supposed to be that you will reflect this point across the axis of symmetry to identify the reflection point. So this is called an RPT. Once again, this step is going to be optional for right now. All right, next, the graph opens up if you find that the A value, the graph opens up and has a minimum if the absolute value of A is, if the A value is bigger than 0, which means that this is a positive number. So the graph opens up and has a minimum if your A value is positive, and it opens up and has a maximum if your A value is less than 0 or a negative number. Once again, it's going to be the same language that we've used in the past when it comes to our A values. The A value is consistent regardless of whatever form that we are talking about. All right, let's go ahead and practice graphing y equals -2 times x minus 1 times x minus 5. The first thing we want to do is identify our x-intercepts. And our x-intercepts is always the opposite of what we see on the inside. And so the opposite of a -1 is a positive 1. So 1, 0 is an x-intercept. The opposite of a -5 is a positive 5. So 5, 0 is an x-intercept. And I'm going to plot these points. Here's 1, 0. And here's 1, 2, 3, 4, 5, 0. The x-coordinate of the vertex, remember that is halfway between your x-intercepts, cut in half. So that is going to be 1 plus 5 divided by 2. So that is 6 divided by 2, which is 3. So that is the x-coordinate. Not only is it the x-coordinate, but it's also the number that will tell us what the axis of symmetry is. So I already know that the axis of symmetry is going to be at x equals 3, and I'm going to take out my highlighter and highlight that axis of symmetry because I know it's supposed to be right there. The y part of my vertex requires me to substitute 3 back into my original problem. So I'm going to write y is equal to -2 times 3 minus 1 times 3 minus 5. I'm going to take care of my parentheses first. So I'm going to write y equals -2 times 2 times 3 minus 5 is -2. So -2 times 2 is -4. -4 times -2, that is going to be a positive 8. So therefore, 3, 8 is my vertex, and I'm going to go ahead and plot that. All you need are 3 points in order to graph this line. It might be helpful, and I'll talk really quick about the OPT and RPT. OPT means pick another point that could fall on this parabola. Like maybe instead of letting x equal 1, let x equal 2. So if I were to let x equal 2, I would have y is equal to -2 times 2 minus 1 times 2 minus 5. So this is y equals -2 times 1 times -3. So that is -2 times 1, which is -2. -2 times -3 is -6. So which is positive 6. So 2, 6 is another point that's on my graph. 1, 2, 3, 4, 5, 6. And I can reflect that point across the line of symmetry. Since it is 1 unit away from the line of symmetry, I can plot a point 1 unit on the other side. And that's going to be located at 4, 6. So this would be called the OPT, and its reflection point would be located at 4, 6. So that's all that means. Once you have at least 3 points, we are going to draw a really nice curve going through those points. Be careful whenever you have 3 points. A lot of people like to just draw V's. Remember, parabolas are U's or upside down U's. All right, going back to minimum and maximum. Our maximum in this case, because it is pointed upside down, is at the y part of our vertex, and the y part of our vertex is 8. So in this case, we have a max value of 8. Our domain is all real numbers, just like you will see in all absolute value functions. And our range, because it is pointing down, that means that we start at the bottom and work our way up. Our bottom is arrows, so therefore it is negative infinity all the way up to our maximum value, which is 8. With a parenthesis around negative infinity and a bracket around 8, you can also say y is less than or equal to 8 as well. Your end behavior, because we have down, down, that means that we will say as x approaches positive infinity, our function is called y, so I will say that y approaches negative infinity. And as x approaches negative infinity, y approaches negative infinity as well. All right, let's go ahead and move on to the next problem, which is a story problem and a contextual question that is something I need you to please make sure that you know and study. This is something that will definitely be on a quiz or a test in the future, or potentially on a quiz or a test in the future, so I really want you to make sure that you understand these types of problems. So it says you are at a pool party and you jump off a diving board. The equation h of t equals negative 0.5 times t plus 2 times t minus 5 models your height in yards as a function of time in seconds. So what they want you to do is graph the function, identifying similar information as to what we did on the last page, and then we're going to do some analysis. So let's go ahead and start. My x-intercepts are going to be the opposite of what I see. So if I see a plus 2, that means that my x-intercept is going to be located at negative 2, 0. And the opposite of a minus 5 is a positive 5, so 5, 0. So I'm going to start off by graphing these points. Here is negative 2, 0, and 5, 0. Next, I need to identify the x-coordinate of the vertex, and that is going to be at x equals the average of my x-intercept. So negative 2 plus 5 divided by 2. So negative 2 plus 5 is 3. 3 over 2, you can write as 3 over 2, or you can write it as 1.5. Typically 1.5 is a lot easier to graph, so you're welcome to use that number. But if you want to work with the fraction, that's fine too. I'm pretty open. So let's go ahead and realize that the axis of symmetry is going to be located also at x equals 1.5. So I'm just going to identify where that's located, and I'm going to draw my quick axis of symmetry. If you want to use color, that's fine too. We typically use color in my class, but for this problem, I'm just going to use my pen because there's going to be other areas that I really want to focus on instead of just the axis of symmetry. So now I'm going to find what the y part of my vertex is by substituting 1.5 back into my original problem right here. So I'm going to write h of 1.5, so that's my t value. I call it my x, but it's really supposed to be t because this is time, technically. So I'll call it my t coordinate and my h of t coordinate. So h of 1.5 is equal to negative 0.5 times 1.5 plus 2 times 1.5 minus 5. And I think that as long as you have it substituted into your formula, you can just use a calculator, graphing calculator, scientific, whatever, just as long as you're able to put it in exactly as you see it. So I'm going to write negative 0.5 times 1.5 plus 2, parenthesis, 1.5 minus 5. I'm going to verify that I wrote it down correctly in my calculator. Looks good. I'm going to press enter and I end up with 6.125. And that is the y part of my vertex, so I'm going to write that down. And I'm going to plot that point. This is going to be an approximation, so it's not going to be perfect, but it's going to be pretty close. All right, I think that looks good. So we have our 3 points. All you need are 3 points in order to graph a function. And I'm going to make it look like a nice little U. And if we need to like curve it out just a little bit more, then I will. All right. Nice, there's my parabola, beautiful. In this problem, I do have a maximum value located at the y part of the vertex, and my y part of the vertex is 6.125. All right, so domain in context and range in context. All right, let's go ahead and remind ourselves of what's going on here. It says you're at a pool party and you jump off a diving board. Okay. If you're jumping off a diving board, what does that mean? Where are you jumping off of that diving board? So this is T is in time, in seconds, and this is H in yards, H of T in yards. So does it make sense for us to say that we started right here? Probably not. So in reality, when we have ourselves a restricted domain, in terms of time, we probably didn't start back here at negative seconds. We probably started somewhere about right here. And then our height went up high, and then we landed probably right here. It wouldn't make very much sense for us to go into negative territory when it comes to our yards, because that is really awkward. So instead, this is where I want you guys to highlight. Please take out your highlighters or separate colors, to highlight that this is the true path that we're interested in. And we should probably find out what that value is at 0. So let's go ahead and identify what is this point right here. So I'm going to let t equals 0. So I'm going to write h of 0 is equal to negative 0.5 times 0 plus 2 times 0 minus 5. And if you want to put that into your calculator, you're welcome to do that. That is negative 0.5 times 2 times negative 5. I just kind of did the math inside really quickly. So that's what I have in my calculator, and I'm going to press enter, and it looks like 5 is my answer. So at 0, 5, so 0, 1, 2, 3, 4, 5. So I'm going to plot that point right here and call it 0, 5 because I believe that we need it. This is where actually we're starting. So our domain is going to start at 0 and go all the way up until this point right here, which X is located at 5, 0. So that is 5. And I'm going to close the bracket because both of these numbers are included. And I am interested in both of them. And so there won't be any infinities. We have a starting point and we have an ending point when it comes to our domain. And in context, this is seconds. My path of jumping off of this diving board started at 0 seconds and ended after 5 seconds. So there's my context right there. My range in context, well, let's think about that. My lowest point that makes sense is 0. I would land, and this is your height in yards above the ground. So if you think about the swimming pool being located right here, and your diving board being located right here, here's your diving board. You're on top of the diving board, you jump up, and then you splash. We are not interested in negative territory. We're just interested in your path of jumping off of the diving board. So our range in this case is our most minimum value, which is 0. So 0 is certainly included, and my context is going to be that we're talking about yards. Going all the way up to our maximum point, not this point, because it's not the highest. We want to go to our maximum, and that's at 6.125. So 6.125 yards. And I'm going to put a bracket around it because it's closed. It's included in our values. All right, let's go ahead and move on to the next question. It says, how high above the water did you jump? So what is the maximum height that we jumped? That maximum height, once again, is 6.125 yards. That was the highest that we reached above the water. What do the x-intercepts mean in context? Well, let's talk about both of them. This one right here, once again, is negative 2, 0. And negative 2, 0 has no meaning in context. And that's because we're talking about time, and there doesn't exist negative 2 seconds. So in an explanation, I think it's perfectly acceptable to say that negative 2 seconds really doesn't exist. At least not in this universe, does it? So the next one is 5, 0. And what 5, 0 means is that it takes 5 seconds to hit the water. That's what that one means. How tall is the diving board? Well, we talked about it right here. At 0 seconds before you jumped off, we have ourselves a height. And in this case, it's going to be 5 yards. All right, cool. If you have any questions over this example, please make sure that you have a conversation with me. You will be expected to do problems like these on your own with doing all of the analysis. So if this was challenging for you, be going through it. Make sure you have a conversation with me as soon as possible. All right, let's go ahead and move on to our last example for this lesson. And that is hints for writing equations in intercept form from tables. Now remember, intercept form is y equals a times x minus p times x minus q. And it has the same a value that we've done before. It is still going to be, the a value in the equation is still half of the second difference, just like before. But we're interested in our x-intercepts. And our x-intercepts, they are going to be found when y is equal to 0 in the table. So that's what you're going to be looking for, because that's what these two x-intercepts have in common. The x-coordinate of the x-intercepts will be the p and the q in the equation. All right, let's go ahead and look at our first example. Down here, you can see I have highlighted as a solo. So that's something that you can work on your own, or you can work on when I have you guys break out and talk to each other when I see you guys next. All right, so let's go ahead and look at this problem. In this table, all right, let's see what we can identify. First of all, let's see if we can identify our x-intercepts. So our x-intercepts, remember, happens whenever y is equal to 0. And I noticed that y is equal to 0 right here at 3, 0. And y is equal to 0 at 1, 0. So therefore, my x-intercepts are located at 3, 0 and 1, 0, which means that I can say that p is equal to 3 and q is equal to 1. So I'm going to use that in my equation. So I'm going to write y equals a little bit of space for my a value that I don't know yet, that I'm going to find. And I'm going to write x minus 3 and x minus 1. So I do need to find what my a value is. So let's go ahead and look really quick. That is the second difference divided by 2. So let's go ahead and find our first differences. To go from 10 to 0, I'm going to subtract 10. And 0 to 6, I'm going to add 6. 6 to 8, I'm going to add 2. 8 to 6, I'm sorry. Yeah, I'm sorry. I think I did that. I don't know why I put a minus there, or plus there. It's a minus 10. Plus 6, and then this will bring me to plus 2. And then over here, I'll have minus 2, and then minus 6, and then minus 10. Or I'm sorry, minus 6, and then I have plus 10 again. I'm thinking that I made an error with this, guys, and I'm pretty sure that these are supposed to be negative 10s. That's what I feel like that makes more sense to me. I'm sorry about that. I'm thinking this is missing a whole bunch of negatives. So let's go ahead and put in these negatives. When I was creating these notes, there was an issue. And so we're going to put in some negatives right here because I'm like, this isn't feeling correct. All right. Sorry about that, guys. Like looking at my notes and I'm like, this isn't matching. All right, here we go. So this is negative, 0, negative, 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 0, negative. Let's try that again. To go from negative 10 to 0, I am going to subtract 10. From 0 to negative 6, I am going to subtract 6. From negative 6 to negative 8, I'm going to subtract 2. From negative 8 to negative 6, I'm going to add 2. From negative 6 to 0, I'm going to add 6. And from 0 to, I think this is supposed to be, yeah, this is supposed to be positive. Sorry about this, guys. What a disaster. All right, so anyways, this is positive, this is 0, negative, 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 0, positive 10. So then this is supposed to be plus 10. That's the only way we're going to get our second difference. All right, so this is supposed to be plus 4, and plus 4, and plus 4, and plus 4, and plus 4. So therefore, my second difference is a plus 4. So my A value is going to be 4 divided by 2, which is 2. Oh, finally made it. So therefore, my answer is y equals 2 times x minus 3 times x minus 1. With my vertex being, well, let's go ahead and look for some symmetry. That symmetry was located right here, and that's supposed to be a 1, negative 8. That's what it's supposed to be. So we're going to say my vertex is located at 1, negative 8. My axis of symmetry is based on the x part of our vertex, and that is going to be at x equals 1. My maximum or minimum, well, because my A value is positive, that means that my parabola is going to be pointing up. And if it's pointing up, I have a minimum value located at the y part of my vertex. So I have a minimum value located at negative 8. My domain is always going to be all real numbers. My range, because it's pointing up, is going to go from negative 8 all the way up into infinity. You can also write this as y is greater than or equal to negative 8. My end behavior, because it's pointing up, is as x approaches positive infinity, y, which is what I called it, is approaching positive infinity. And as x approaches negative infinity, y approaches positive infinity as well. All right, so I appreciate your patience with that problem. Hopefully I didn't confuse you too badly. And hopefully the U try is correct, which I'm looking at it and I'm seeing that it's not. So let me go ahead and update that. It's supposed to be a negative 8 and a negative 8 and a negative 20. So something happened with my negative, so just please forgive me with that, guys. But otherwise, I appreciate your patience and your time. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.